Hey Joe, Graybench Electronics here. I got a busted fuzz face that needs repair. I'm going to figure out what's wrong with it, fix it, and maybe do some modifications to the pedal as well. We'll pull the transistors out, test them, see what's up with that. So if that sounds interesting to you, then stick around and let's get to work. All right, so little confession, I've never actually owned one of the full-size fuzz faces. I've been building pedals with Germanium for multiple years now. I've been building fuzz faces, Germanium and silicon, but I never actually owned a full-size fuzz face. And I knew I wanted to do one on the channel because we already done some Germanium stuff and it was just, the theme was fitting. And this one, I initially bought it as expecting a full working unit, but it ended up having some problems. Right now there's absolutely no output from the pedal. Adjusting the controls do nothing. So we're going to figure out that first. Also, a couple things just with this one specifically. The knobs are very gritty. So when you twist them, you can feel some grit, like it's scraping on the enclosure. Could be the knobs are sunken too low to the enclosure and just need to be lifted up a little bit, or it could be something else going on. Also, the couple of knobs here can rotate past the stops on the potentiometer itself, and you can start to feel that, which means that the pots are actually loose in the enclosure. So we're going to have to check that out. Input and output jacks seem fine. You can see here the pedal is sort of rotating. That's because on the back here there are no rubber feet and there's just a single screw here which holds on the back panel. The rubber feet were probably taken off to put Velcro on, but when the Velcro comes off and there's no rubber feet left, it will rock on whatever's sitting there. If there wasn't a screw, then it would sit flat, but there is, so now it's doing a disco thing just on the screw. Pedal's in pretty good condition. Foot switch is here, Dunlop. One annoying thing that I didn't realize, not having had one of these, is that the nut that holds on the foot switch is buried underneath this rubber foot pad, so I'm not exactly sure how I'm going to get that out. But let's crack this open and see what's going on inside. One long screw holding on the back panel, got a piece of foam to press down on the battery. Yeah, we can see the pots here, like this one's twisted, this one's down, and yes, this one is loose. They look like CTS pots, which is a nice touch. Printed circuit board there, PCB. Battery is in here, and it just flops around, which I don't love. I guess when the cover is on, the foam will come and press down on the battery. Still don't love that floppiness. Let's see about getting this. Oh, I see. So the foot switch is actually holding the PCB, so we have to get the foot switch out in order to look at the PCB. But like I already said, on the other side, the nut that holds on the foot switch is buried. So let's try. Just thinking about it a little bit. Maybe just some needle nose pliers to sort of dig down in here and grab that. Hopefully it's not too tight. No, it's actually not tight. So what I might also have to do here is just spin it from one side. If it's not too tight, you should be able to just kind of rotate that nut. Yeah. I'm trying not to damage the rubber foot pad too much, but I feel like I'm going to damage it a little bit no matter what. I hope somebody else has figured out a better way to do this, because this is annoying. Okay. That just comes out there. Germanium transistors in there. T01 package. They are marked. One is marked DMI158. The other one is WW158. So that's similar to NTE158, which is you'll see that germanium transistor in different fuzz faces, or I should say just different germanium fuzz pedals. NTE158 is often just a relabeled something, some whatever germanium transistor that NTE got their hands on. NTE being just a distribution company. I don't know if they actually make transistors of their own. There are a couple little trim pots here, which presumably are going to be the collector resistors or somewhere on the collectors for the two transistors. And all the wires are going into this header connection here. Couple filter caps, looks like both 330 microfarad filter caps. That's the 22 microfarad emitter bypass cap, filter caps, germanium transistors, potentially the 2.2 input cap, and presumably collector trim pots. Pot values. Actually, let's get those pots out because they were not happy with their situation. It's almost like these holes were drilled too big, and to solve for that problem, Dunlop got these brass inserts where it gives a widening. It sort of widens the sleeve of the potentiometer, so it fits better in that hole. The problem is a couple fold though. Well, first off, it's mostly flat there. There's a little bit of a curve to where that pot is tightening into the enclosure, but they didn't flatten the anti-rotation tab on these pots, and so it's always going to be canted inside that hole. You're never really going to be able to tighten it. That's one problem. Did they do the same thing over here? Now, see, on this one, they flattened the tab, so someone just, you know, it was 4 o'clock on Friday and they just forgot to do it. It would be nice to just have the correctly sized holes. Okay, this one had the flat washer inside over top of the star washer here, preventing the star washer from doing anything. So that should be on the outside like that, so that's great. It makes me honestly think that someone else has been in here messing with this. And yeah, actually it does look like the transistors have been resoldered. There's some extra flux around there that's not on the other solder joints. So not sure what that's about. Same thing on this jack, flat washer inside, blocking the star washer. Okay. So now we've fully liberated the circuit from the enclosure. As far as that nut problem for the foot switch, my first thought was to just open up this rubber a little bit, just so we have some room to get in there with some pliers easier. Although trying to cut that, it's never going to look nice. So we know the pedal's not working. Let's see if we can see, first off, just any broken wires. It might give a clue. Got ground wires for everything. Pot. All these wires look good. The one thing I do see is the shielded wire going to, I guess this would be the output jack. It has the shield attached on both sides, assuming that this wire goes somewhere, which generally you don't want to do. You want to have the shield connected at one side, but not the other. Let's pull out the germanium transistors out of the PCB and test them and see what we're getting for that. Okay, so I was able to extract the germanium transistors from the PCB here. So we'll do some testing on those in a second. But unfortunately, as I saw before, it looked like the transistors had already been messed with once, and then another reheat. The PCB's in pretty rough shape. We've lost a couple pads here on the top. The bottom side looks better, and I cleaned it up as best I could, but I think one of the things that would be cool for this anyway is to put one of the vintage PCBs that are available in instead of this sort of more modern PCB. Okay, so got the transistors out, got the trim pods out. I went for the foot switch, but there's too much heat. I know just doing this before, you're gonna wreck the foot switch trying to get it out of there. So we're gonna skip that. I have other double pull, double throw, or even triple pull, double throw if I wanted to do a LED for indication. This is a little component that was between the Q1 collector and Q2 base. It does have 3 red stripes, so it could be maybe like a 222, like a 2.2 nanofarad cap. And then this should be a 2.2 micro input cap, tantalum. Tantalums are nice to save because tantalum mining is kind of a dirty business. So where we can use ones that are already made rather than buying new is worthwhile. Next step, I'm going to get one of those vintage boards. And what's cool is that this enclosure appears to have the mounting screws for the more vintage style fuzz face boards, probably because they use this enclosure for a bunch of different versions of the fuzz face that Dunlop makes. So I'll get one of those boards that's meant to meet up to these screws, and then we will populate that new board, hopefully with the transistors that we're about to test. Come on. And we'll use some of these parts as well. Probably redo all that wiring though. So we have the 2 resistors, or transistors. Now we should be able to measure the specs and tell which one's Q1 and Q2, but just for continuity, pretty sure there's one here that says DMI 158 and one says WW 158. The DMI was the Q2 and the WW was Q1. So we'll see if the specs coincide with that naming convention. All right, I've got the trusty Atlas DCA Pro DCA 75. I've got my 2 germanium transistors. This should be Q1. This should be Q2. I've waited a couple minutes to let the transistors come back down to room temperature. They would have warmed up during the desoldering process, which is going to change the measured specs through the DCA 75. So you got to let them cool off for a couple minutes. Let them just, settle back down to room temperature. After that, I'm not going to handle it with my hands because even the temperature or the heat from your fingers can cause fluctuations. Germaniums are notorious for that. Okay, Q1 PMP Germanium BJT makes sense for the NTE 158 or DMI 158. And leakage is 143 microamps, which is, I would say, on the high side of acceptable. Let's go for Q2 here. Q2 is, interestingly, 78 HFE, and leakage is 105 microamps. So a little bit less HFE, a little bit less leakage. Interestingly enough, though, 78 is significantly less than what's usually recommended for HFE for Q2. Q2 is usually 120 HFE. What does that mean? That means that either Dunlop knows something we don't and is picking a lower HFE for Q2. It's reasonable to suspect that Dunlop has some inside information. However, we know that fuzz faces, when they were built, they weren't testing for HFE. They just threw them in. That's why some fuzz faces will come out sounding good, some wouldn't. Now, it's not like you couldn't bias up a lower HFE Q2. Sure you could, and that's one of the reasons why you put a trim pot in for the collector, at least on Q2, if not Q1 as well. However, usually we go for a higher HFE on Q2 to get that really thick, saturated, full fuzz sound. If anything, I would have swapped these and put the lower one for Q1 at least. What we might do, I think what probably would make sense, is when we get that new PCB, we will put sockets in for the transistors and maybe play around with that a little bit. I'll probably stick with these just because it's what, well, I was about to say it's what Dunlop did, but you know what? We saw on that board that the transistors have been messed with. Now, I'll look and see if these transistors came with fuzz faces, if it's a known set or known part numbers that come with fuzz faces. If they're not, then someone else swapped them out. But if they are, then presumably there's something there, and maybe someone else is troubleshooting or something. Who knows? But all right, so I think we're going to pause here. I'm going to get one of those fuzz face boards, and then we'll pick up. All right, got the replacement PCB. This is a vintage style fuzz face board from Pigeon FX in the UK. It's actually the only like vintage fuzz face board I could find. Usually I see a couple on Reverb or eBay, but this is the only one I could find. So we'll check it out. I believe it was $6.50 British pounds. Let's go ahead and crack it open. Alright, so it's got sort of a vintage brown epoxy board, it looks like. If you want to know what thickness, 1.5 mil or 1.6 mil thick. And it does say Arbiter Electronics on the back. Alright, cool. Let's see if these mounting holes match up to our fuzz face. Okay, so there are the circuit board mounting holes. And looks like they do. Let's find out what threading those are. They look a little small. Alright, I've got to look up what the screw size is for these enclosures. But it does look like the PCB has the correct spacing for those mounting holes. Also, I hunted down some Mojo components, because why not? Go on a vintage board, might as well go full Mojo. Phillips 22 microfarad electrolytic cap. This will be for the emitter bypass or the fuzz control on Q2. I have a 10 nanofarad output cap, I believe, and this is a 2.2 microfarad input cap, and our 2 germanium transistors. So I'm going to do a little more research and find out the screw size for the PCB, and then we'll populate the PCB with the components and move on to installing it into the enclosure. All right, I've been playing with this a little more, and I've determined that number 6 by 32 screws are in fact the correct size for these mounting studs, which is what I would expect. Number 6 by 32 is like a pretty standard fastener size for guitar pedals. It's the same size as like Hammond enclosures and whatnot. But when I was going to just test fit the PCB, I found that the holes are actually not quite aligned. It is maybe a millimeter off. See that there? If you see the hole on the right there, it doesn't quite line up. And it's one of those things where I could probably force the screw in and it would go okay. But it's going to stress on the PCB, it's going to stress on the machine screws, and it's just not the right way to do it. So in my opinion, and I also want to say that this isn't necessarily Pigeon FX's fault for the board, because the spacing of these studs could be different for different fuzz face enclosures. I don't know. But we have to give a little more clearance for the PCB. And in my opinion, the right way to do this is to just widen out this hole here. So just make it into an oval as opposed to a hole or a circle. There is copper around this hole here, but the copper doesn't connect to anywhere else in the circuit, so it's not crucial. And I'm probably going to use this side for a little terminal lug, like a little solder lug here, like that, for ground. So widening this out and damaging that copper trace is not a big deal. So that's the next step, is going to widen this hole out a little bit so we have enough play to get this mounting screw in there. It probably don't have to make it so wide that you will see it underneath the head of the screw, so it should be fairly invisible. And then I'm also going to, even though I don't think it's necessary, because once you have the solder lug and the screw going in there, the screw will be contacting the chassis through the threads, and then the screw will be touching the solder lug here. I don't think it's necessary, but just for thoroughness sake, I'm going to take the paint off the top of this mounting stud so that we're certain that there's a good ground connection to the enclosure. So that's 2 steps. We're going to widen out this hole a little bit to get the screws to be able to go in straight, and going to take the paint off this stud. All right, to widen out the hole on this PCB, I have it mounted here in this PCB holder, which it's not super secure just as a holder, but it gives me a good place where I can get my hand on it and hold it all down. And even up here, hold it on the PCB itself. Because otherwise it's a little bit fiddly and hard to get in the camera. To widen the hole, you could use an automatic tool like a Dremel or some kind of rotary tool. I'm just going to use this round needle file. Just do it by hand. It shouldn't take long at all. But a word of caution, if you're going to be doing any kind of filing or milling on epoxy boards like this, it's good to wear a respirator or some type of air filtration mask because the dust created by these boards is toxic. All right, so I got the PCB now fitting just fine in the studs for the PCB mounting for the fuzz face here. It didn't take a lot. As you can see, that hole on the right is just slightly ovalized. See there, if the copper trace was concentric before, it's not even a millimeter, it's half a millimeter maybe. Just widening it up just enough so that the screw can go in without an angle, so it's not going to strip out the threads in the mounting studs here. So now that the PCB is mounting nice, we're going to move on to populating the PCB. Okay, so I'm planning out sockets for the PCB here. You can clearly see where the transistors are meant to go because the emitter, base, and collector are marked with E, B, and C. And luckily they are a typical 0.01, it's actually 0.02 spacing. It's essentially skipping a hole. And in fact, that's causing a bit of a problem because the transistor legs for these germaniums that we pulled out of the original fuzz face PCB, the legs aren't really wide enough or long enough to get to the mounting holes. So I have an option. I can put in some jumpers to connect the middle two sockets here into the edges, just a little like lead wrapped around and connecting the inside to the outside. That way the transistor can fit to the inside three and it'll be making connection to the middle and the two outside. That, or I could figure out some way to lengthen the leads on these transistors, which could be as simple as just tacking on a little extension lead to those. So I'm going to think about it a little bit more and decide what I want to do. I'm leaning towards the socket route because I want to leave the transistors more or less with as little heat as possible. It's one of the reasons we go with sockets, especially for germanium transistors. So that's what I'm leaning towards right now. It'll also be invisible. The little leads, you're not going to see them underneath the black plastic that's part of the socket. They'll be invisible under there. So that's what I'm leaning towards, but I'm going to think about it a little more. Alright, I've got the fuzz face PCB all populated. Next step is going to be dropping this into the enclosure and using it to see what kind of wire length I need to run for the potentiometers. You may notice that I've left out the 8.2K Q2 collector resistor. That is intentional, and we're going to come back to that, and I'll explain why I've left it out at this point. So let's go to the next step and put this in the enclosure and see what kind of wires we need. Alright, the pedal's all wired up. So back to that 8.2K collector resistor, which I left out of the PCB. The reason I did that is because the bias point on Q2 is very important to the sound of the fuzz face. It's one of the reasons why Some fuzz faces back in the old days sounded good and some didn't, and people would hunt for the quote-unquote good ones. It was usually due to a misbiased Q2. What I've done here is substituted, just with these spring leads, I've substituted in a 25K potentiometer in for that collector resistor, and I can adjust this for a certain voltage at the collector. So that's what we're testing for here. I have the multimeter set to DC voltage. You'll notice the red lead is actually to ground here. That's because this is a positive ground pedal. So in order to read positive measurements on the fluke meter, the positive lead has to be to ground, and negative is to the collector of Q2. This orange lead is coming over here to the collector, and the black lead from the multimeter is set to that same lug on the potentiometer. So we can apply power to the pedal by shorting the battery to ground, or I should say connecting the ground through the circuit. So we can see here we have about 5 volts on the collector. Technically it's negative 5 volts, depending on what you're calling ground. So we can adjust this potentiometer here until I see, we want to see approximately half the supply voltage. Which, all right, so there's about 4.5 volts. Fault voltage is falling a little, but that's okay. The germaniums are just settling in. So now we're going to measure the resistance across the potentiometer and use a fixed resistor in that spot for the 8.2K to give us our proper bias at that point. All right, so now I've got the potentiometer clipped into the multimeter here, and we can see it wants a 16K instead of 8.2K to get that 4.5 volts on the collector. Okay, got the fuzz face hooked up for a little audio test here. I'm running an SM57, a bit off axis on a Celestion V30, which is connected to a modded Baseman sort of style circuit, like 5F6A style circuit. Fuzz face, volume, and fuzz are both dimed. I got a Strat. This Strat, I'm on the bridge pickup. This bridge pickup is wired just straight to the pickup, so there's no tone control, so it's a little brighter than other Strats. And what else? I have huge power lines right outside my window, so I get a whole bunch of hum, but there's a whole bunch of hum and noise anyway because it's a fuzz face. So here's the clean tone. So a little dirty if I dig in, but can clean up too, which is right where I like to put fuzz faces, or like that's how I want my amps to be when I play with a fuzz face. right, that wraps up the repair and I guess modification now of the Dunlop Fuzz face. If you have any questions, feel free to leave them in the comments. If you enjoyed the video, I'd appreciate you hitting the like button and subscribing, and hit the notification bell if you want to know when I make new videos. And hey, by the way, if you liked the sound of this pedal and you want to own it, guess what? You can. It is for sale. Check for the reverb link in the description. I am Joe from Graybench Electronics. Thank you for watching.